Hello everyone and welcome to the lesson Trigonometry 2 KCC 2017 paper 1. The question reads, in the figure below, not drawn to scale, AB is equals to 11 centimeters, BC is equals to 8 centimeters, AD is equals to 3 centimeters, AC is equals to 5 centimeters, and angle DAC is a right angle. Calculate correct one decimal place. A, the length DC, 2 marks. B, the size of angle ADC, 2 marks. C, the size of angle ACB, 2 marks. D, the area of the quadrilateral ABCD. So let's go straight to the first part of the question, which is the part A. Now part A, you're supposed to get the length DC. So to get length DC, we shall use triangle ADC. Triangle ADC is the one that I'm shading. Now you notice that this one is a right angle triangle. So to get DC, we shall use Pythagoras theorem. Pythagoras theorem are supposed to be used like this: the base squared plus the height squared. Get the square root of that. This will give 9 plus 25. If you get the square root of this, you shall get it will be square root of 34, and this will give correct one decimal place. Don't forget that is supposed to give the answer. This will give 5.8 centimeters. So that is simply how you're supposed to solve the first part, by using the Pythagoras theorem. Let's go to the second one. The second one is the size of angle ADC. Size of angle ADC. Now you notice that to get the size of angle ADC is here. We shall use the same triangle. So B, ADC. I will extract that triangle here. So let me extract this one is ADC. So A is here, D is here, and C is here. Then the measurements are given. This is 5 and 3. So this is 5 and this one is 3. So we need to get this angle. So angle ADC will be obtained by, just think of SOHCAHTOA, sine, cosine, and tangent. Which one is going to be applicable here? Now tangent will work well because you're given the opposite and adjacent. So you get tan of theta would be opposite, which is 5 over adjacent. To get that angle, you get the tan inverse of both sides. Tan inverse of tan theta will be theta. Tan inverse of 5 divided by 3 is what is going to give us the answer. So when you get the tan inverse of 5 over 3, so the tan inverse of 5 divided by 3 will give 59.0 degrees, correct one decimal place. So that is how you're supposed to solve the second part of the question, and that one will give you 2 marks again. That part of the question is the size of angle ACB. The size of angle ACB, look at this diagram. ACB is there, so I will extract that one again here. So C, so ACB, so ACB is here. I'm trying to extract this. So A is there, C and B. Then we indicate the measurements. The measurements are 11, 5 and 8. And 11, 5 and 8. So this is the angle that you're required to get in the triangle. So how do we get this angle? Since this one is not a right angle triangle, we can't use SOHCAHTOA or trigonometric ratios, that is a sine, cosine, and tangent. So we'll be required to think of using the sine rule or the cosine rule. We can't use the sine rule since we are not given any angle, but since we are given all the sides, it is easier to use the cosine rule. So cosine rule would be used. So how do you use cosine rule? To use cosine rule, we shall let this side to be A, this side to be B, and this one to be C. This is how the cosine rule should be used. C squared is equals to a squared plus b squared minus 2ab cosine of c. That is the cosine rule according to what you're given there. So substitute these. So c squared will be 11 squared is equals to a squared is 5 squared plus b squared is 8 squared minus 2 times a times b, which is 8, times cosine of c. So simplifying these, 121, that is 11 squared, then this one will be 25 plus 8 squared will be 64 minus 2 times 5 times 8. This will give 10, this will give 80 cosine of c. Get 121 is equals to 25 plus 64 will give 89 minus 80 cos c. Then let us bring this to the side. Can bring this on to this side, and then we can take this on to the other side, so that we can get 80 cosine of c is equals to 89 subtract 121, and this one will give 80 cosine of c is equals to 89 subtract 121. This is 89 subtract 121 will give negative 32. Divide both sides by 80. You remain with cosine of c is equals to negative 32. Divide by 80. So this will give the cosine of c is equals to 32 divided by 80. Give 0.4, negative 0.4. Now when you get negative cosine, you need to think of something here. Think of the unit circle. All students take coffee. Where is cosine negative? Cosine is negative in the second quadrant and in the third quadrant. And since this one is an obtuse angle, it is probably in the second quadrant because it is an obtuse angle. So what you're going to do to get the cosine of c, we shall get the cos inverse of both sides. The cos inverse of cosine of c will be c. Then the cos inverse of, we shall not get the cosine inverse of negative 0.4. Let us just get the cosine inverse of 0.4. The negative sign has already shown us where the angle is. The angle will be either in the second quadrant or the third quadrant. But since this angle is obtuse angle, it will be in the second quadrant. So when you get this, c will give you the cos inverse of 4. So the cos inverse of 0.4 will give 66.4 degrees. 66.4 degrees is not the answer because that is the first quadrant. To get the angle in the second quadrant, we'll get 180 subtract 66.4 degrees. So we get 180 66.4, and this will give 113. This will give 113.6 degrees. So that is how you're supposed to do that. So the negative has indicated where the angle is in the second quadrant, and you already know this angle is obtuse, cannot be more than 180. So that is how you're supposed to do that. So let's go to the other part of the question, and that is the area of the quadrilateral ABCD. The area of the quadrilateral ABCD. So area of quadrilateral ABCD. So to get the area of this quadrilateral, we shall get the area. You can see it is divided into two triangles. So it will be the area of triangle ADC. So we shall get the area of triangle ADC plus triangle ACB. As you can see there, triangle ACB as the area of triangle ACB. That will give now the total area of the quadrilateral. Triangle ADC is very easy because it's a right angle triangle. We should just use a half times base times height. So let's go to triangle ABCD, no, ADC. So the base is 3, the height is 5. So half times 3 times 5. Then plus the area of triangle ADC. ADC is what we have here, no, ABC. And this is ABC. Let me see whether that is what I've written. Yeah, or ACB. ABC is okay. So this is the triangle that you're supposed to get the area of, and we have this angle is 113.6. So automatically you can use a half AB sin theta, a half AB sin theta, a half AB sin theta, whereby the two sides are 5 and 8. The angle between is 113.6. So I have AB sin theta. So I have times A, we just confirm, the two sides are 5 times 8. 5 times 8. This is a 5 times 8 times sine of the angle between, which is 113.6. So these will now give the whole area. So these will be a half, this will be 15 divided by 2, this will be 7.5 centimeters squared, plus, now this one you have to get, this will be 40 multiplied by sine of 113.6 equals to divided by 2. So this will be 18.3 centimeters squared. So when you add this 7.5 plus 18.3, you get 25.8 centimeters squared. And that is simply how you're supposed to solve that question. Thank you.